Now question 2, z equals -1 plus I over root 3 plus I, expressed in mod arg form. First I'm going to realise the denominator here by multiplying by the conjugate. Doing the maths, you get negative root 3 and you get, as the other part of it, minus I squared. I squared is 1, so that'll -1, so that'll make +1. Plus you'll get root 3I, and you'll also get minus times minus is a plus 1I. That's the numerator. On the denominator, difference of squares gives me 3. I times I is I squared, minus I squared is plus 1. 3 plus 1 is 4. So we have as our complex number negative root 3 plus 1 over 4 plus root 3 plus 1 over 4I. So expressed in mod arg form, and I get the modulus of z. The modulus of z is going to be equal to the square root of x squared plus y squared. Simplifying that down, it will be over 16, gives me 3 minus 2 root 3 plus 1 plus 3 plus 2 root 3 plus 1 all over 16, which means that our root 3's cancel, leaving you with 3 plus 1 plus 3 plus 1, root 8 on 16, which is equal to 1 on root 2, and I can rationalise the denominator and get root 2 on 2. Okay, continuing on, to find the argument of z, I say that tan of theta, where theta is the argument, is equal to y over x from over here. That divided by that, the 4's will cancel, so give me root 3 plus 1 over, I'll actually write that as 1 minus root 3, probably a little bit more convenient. Again, before I go any further, I could plug that in the calculator. If I plug that into the calculator, I'll find that theta is in fact 105 degrees, which means that theta is equal to 7 pi on 12 in radians. So therefore z is equal to r cos I sine theta. In this case r was root 2 on 2 cos I sine 7 pi on 12 in mod arg form. The question goes in to ask for the cos of 7 pi on 12 as an exact value. Cos 7 pi on 12 is equal to the real part of this expression here. So I'll root 2 on 2 cos 7 pi on 12 is equal to the real part of this expression, which is the real part of z, which from over here is equal to 1 minus root 3 on 4. So cos of 7 pi on 12 will equal 1 minus root 3 on 4 times 2 on root 2. Simplifying that down, 1 minus root 3 over 2 root 2. That can then be rationalised further. I'll run out of paper.